I want here to be calm. I want here to be calm. Okay, that means if I'm done with today's lecture, I'll be entering into, since she has entered into work, energy and power. That work, energy and power should be chapter what? Chapter 5, right? Okay. Okay. Now, last time we discussed resolution of vectors. So I'm sure I must cover this topic today. Resolution of vectors. You know, last time we discussed we talked on how angle is inclined at different angle, right? Calculating their magnitude and their direction. Now today we are going to talk on resolution of vectors. Now, what is this resolution? Vectors can be resolved vertically or what? Horizontal. Now, you can have about up to so many vectors inclined at a place. Now, you can resolve them before you can get their calculation, their magnitude and their direction. You must resolve them vertically and horizontal. That is perpendicularly. Now, if you have this resolution of vector, if you have these two vectors inclined at right angle to each other, with the parallelogram, which is the resultant drawn from the center. Therefore, you can have that angle AOB is equal to, you can resolve this vector. This is y, this is x-axis. Those vectors, when you have so many vectors inclined, or more than two vectors, they can be resolved into horizontal and vertical. If you resolve horizontally, which is ax, if the vector is a, we have a unit vector a. For it to resolve into horizontal, given by ax equals the modulus of a cos what? Theta. For it to resolve horizontally, which is ax, ay. Then resolving vertically, you have that the modulus of y is equal to modulus of a sine theta when you're resolving horizontally and vertically. So without wasting our time, let's see these vectors. They are up to two vectors and three inclined at a place. If you have these vectors now, you have this vector. And you are asked, these vectors, these are a vector C, this is a vector A, that can give this a vector B, and this is X, this is Y. Now you are asked to calculate the magnitude and direction of this vector. We don't know, this is vector B. B, no, they are all in Newton. They are all in Newton. We are asked to calculate their magnitude and their direction. For us to calculate their magnitude, we first of all resolve them. We must keep them into horizontal and vertical. Now, for us, we have to resolve this vector into vertical and this vector into horizontal. Then, how do we do that? First of all, for us to get AX, the sum, we have to sum the sum of AX, the sum of, or you can call it the sum X. Let's not use X because we have the sum X, which is the horizontal axis. The sum X, the X I'm talking about is the horizontal axis, is given by AX plus BX plus Cx. You have to resolve this A into horizontal and also resolve it into vertical. You also have to resolve this B into horizontal, also resolve it into vertical. Also have to resolve C into horizontal, also resolve it into vertical. Then the sum of this now, which is the sum of, you also calculate the sum of your y, which gives you ay plus by plus cy. Now calculating the magnitude. The magnitude now, which is the resultant. For you to calculate the resultant R, which will now give you the sum of x squared plus sum of y, you square them all over what? Square root. Remember. Now, when we resolve this thing now, you only have x and y axis. If you resolve this thing into horizontal, you only have x, only two axis is what you're going to have. You direct them to this right angle triangle. If you get the sum, all the sum, let's assume that all the sum of ax, if you are being given figures, all the sum of ax now, if all the sum of ax is equal to a figure, all the sum of ay is equal to a figure, you can now come and write them here. The sum of y axis, you write the figure, then you only have two perpendicular, you only have a perpendicular, the two forces will now be perpendicular to what? Each other. They will no longer be scattered as such. That is what we do. Then for you to calculate their resultant, then calculating their direction, which is the theta. The theta becomes tan inverse of sum of y all over sum of what? X. That is your direction. So now let's see this and let's practicalize with an example. Let's use the example in your book to do that solving. Let's see this diagram they drew in your textbook. I'll only do then I'll give you one as an assignment and move to another thing. Then we'll have example. Let's see this example 1. Now if you have these two vectors, if you have these three vectors, first of all we have this axis is y, this axis is what? X, sorry. This axis is minus y, minus s, right? We have these vectors inclined. 1, we have 4. Horizontal is 4 Newton. You know, remember we use arrow to denote our direction. The other one becomes, if this is equal to 2 root 2, and it's inclined at an angle 45. Then we have another vector, 6 Newton, in the vertical direction. You are asked to calculate the magnitude and the direction. The magnitude simply means the resultant. The magnitude and the what? Direction. The magnitude is the resultant, while the direction is the angle. First of all, you have to resolve them into horizontal and vertical components. How do we resolve them now? Resolving into horizontal, that is x. To resolve x, resolving into horizontal, we have that x is equals, this one is under x-axis, right? 4 plus, we have to resolve, this is the only vector that is out. 4 plus, this is already in vertical, so this is the vector we are going to resolve, the one that falls in there, we are going to resolve into horizontal, and when resolving into horizontal, we have a negative x. We have into brackets, plus into brackets, minus 2 root 2 cos 45. Remember, I told you that ax is equal to what? A modulus of what? Cos what? Theta, when you are resolving horizontally. The horizontally is what? Cos 45. Now, when we have 4 plus this, then this minus effect, then you now have 4 minus 2 root 2. Cos what? What's cos 45, class? Into bracket cos 45, what will you have? Press the calculator. What is the code? 45. Zero point. 0.7. Make it to 4 decimal places, please. 0.70. Now, multiply 2 root 2 times this. What is it going to give you? 2 root 2 times that minus 4. What will you have as the answer, which is your x? 2 root 2 times that minus 4 will give you what? Will give you what? 2. Do it yourself and get the answer. Now, once you get 2 Newton, you are getting for your x-axis. Now, remember, no matter the argument that we have too many forces, sometimes you can have a diagram where you have like up to different forces. That is not just only what you can have here. They will give you an angle. You have here. You have to resolve all of them into horizontal and vertically. Now, since it's only this one, this is what we have resolved them into vertical, horizontal. Let us see. That is for x. Then resolving into vertical, we have the vertical. They gave us 6 Newton already. 6 plus resolving this. This is the vertical resolution, and it's directed towards the what? The negative direction of what? Y. This now becomes minus. How do you mean that this thing is here? It would have been positive direction of y, but negative direction of x. How do you mean it's here? It would have been positive of x and positive of y. Now, if you are resolving, this is the way you resolve it. Now, it goes to this negative direction of y. We now have plus into brackets minus 2 root 2 sine 45. Whatever you have, this minus affect this, giving you 6 minus 2 root 2 sine what? 45, which is equal to 4 Newton. Calculate it and have it. Now you have resolved the whole of this vector that is being scattered into right angle. They are now at perpendicular to each other. You only have x and y what? As is. That is just resolution. You have resolved, what you have is s and y. You can now redraw this diagram. This diagram can be redrawn. When you redraw this diagram, you have vertical and horizontal. This is just what we have. We have that our I is 6 Newton. Sorry. Our y is what? Our y is 4 Newton. Our x is what? 2 Newton. Then, this is now for, we are now calculating this is now for us to get the direction. We can come from here to here, alpha. Here can be our resultant. Remember that the resultant is the diagonal drawn from the point of intersection. You can still complete this, making it an angle. Now, we have changed this dot vector into what? Right angle what? Triangle. We have resolved them into horizontal and into vertical. So all we are going to do is now to start calculating our what? Our resultant or our magnitude. You must resolve the vector before you start calculating. Then let's now calculate our resultant. Our resultant equals x squared plus y squared, all square root, right? And r now becomes 2 square plus what? 4 square, all what square. That r now becomes 4 plus 16, right? Which is equal to 20 square. That 20 we can change it to, can put it in square. We can also that it is equal to what? If you have, can be 4, maybe let's have 4 root 2. 4 root 2, remember you can have pardon? You can have, if you can tell, we can have 16. Okay, sorry, 5. 2 root 5, right? 2 root 5, meaning that you can have 2 root 5 is no, I want us to put it in root form, please. Let's put it in root form. You have 2 root 5. Which is, this thing simply means square root of 4 times square root of what? 5. That's what it means. Square root of 4 is 2 that of 5 will remain 5. Perfect square of this is the perfect square. So you can change this now by square root of 4 times square root of 5, which gives you this. Square root of this is 2, which is 2 root 5. Right? Now this is our result. Our resultant now becomes 2 root 1, 5. We have gotten our resultant. Then we want to calculate our direction. The direction, because it is inclined at what? Theta. We now say that our direction theta is equal to tan inverse of y over what? X. And y is equal to what? 4 all over 2. Tan inverse of 4 over 2. Which is equal to what? Remember, it's theta. First of all, you did this. If you divide it, what do you have? Theta is equal to what? 63 degrees. Remember how to find your tan inverse. Second function, tan of that, you have your tan. So this is what you do. Once you are being given different vectors, you have to resolve them into horizontal and vertical, making them to have making the two vectors to be perpendicular to each other. Once they are, you can now get what you want. Now, take this under that and do during your leisure time. So I can move to another thing because this vector we must finish today. Now, 4 forces. Take this. 4 forces act as shown below. 4 forces act as shown below. Calculate their magnitude and direction. 4 forces act as shown below. 4 forces act as shown below. Calculate their magnitude and direction. You have this. This is 10 Newton. This is 10 Newton that has a 30 degrees. This is 15 Newton that has 60 degrees. Then here is 9 Newton on the negative aspect of y. Then here is another vector of 12 Newton. Another vector of 12 Newton at angle 40 degrees. Calculate, this is Newton, calculate the magnitude and direction of these vectors. First of all, that's the assignment. So you have to resolve them into horizontal and vertical. Once you resolve them into horizontal, you have this diagram. Then before you can calculate some, take note of that. To be submitted next week when we meet. Copy that, please. This is 9. This one this line is a negative aspect of y. You have 9 Newton. This one is another. You have a vector 1, 2, 3, 4. You have about 4 vectors inclined at a place. So you have to resolve them into horizontal and vertical. You only have 2 vectors that are perpendicular to each other before you start solving. Multiplication of vectors. That is our resolution of vectors. So go and carry out this assignment. Multiplication of vectors. Multiplication of vectors. If a vector is multiplied, multiplication of vector, If a vector is multiplied by a scalar, if a vector, let's say unit vector is multiplied by a scalar, if a vector A is multiplied by a scalar product S, it gives us another vector, let's say B. Meaning that the magnitude of this B will also be equal to X dot magnitude of A. Meaning that these two vectors, they are in the same direction. The vector, when a vector is multiplied by a scalar, let's use S as that scalar, it gives you another vector B. And the magnitude of two of them, they are in the same direction. Now, this vector can also be multiplied by two. This vector multiplication is going to center on lines by two vectors. Another vector multiplication by two vectors. There we have what we call the dot product and what? Cross product. Multiplication by two vectors. Let's discuss first the dot product. Multiplication of vectors by two vectors. Yeah, we have what we call the dot product and the what? Cross product. Now let's take dot products. Now how do we define dot products? Dot product of A, if you have two vectors A dot B, is defined as the modulus of A over the modulus of B cos theta. This is the definition of the dot product. The dot product is also known as the scalar what? Product. Then we have about the cross product, also known as the vector what? Product. Now where A dot B means what? A dot B means what? Scalar. Theta means the what? The angle or the direction. The dot product of a vector is defined as this. Then we have some applications of these dot products. Some applications of the dot products of a vector. Some application, one, in concept of work. You can use it in the concept of what? Work. Work is given by force times distance. If you have this body inclined at an angle, if you have that B is equal to the force, this is the angle. Then you have that A is equal to the what? The displacement. Remember, you can't talk about concept of work, start talking about what? Displacement or the distance, force times what? Distance. Meaning that the dot products can be equal to, as one of the applications is in the concept of what? Work. Can be applied in the concept of work. Now when you go further, if you want to calculate the work done, maybe if you enter frictional forces, that is where you see this application. If you want to calculate the work done, you can have that F cos theta. Meaning that you can also have it to be F, apart you can say F dot X can be equal to Fx all over cos what? Theta. That is force and displacement, which you know we use S as displacement in physics. Now, note, if theta, the angle is at 90 degrees, no work is what? Is done. If theta is at what? 90 degrees, no work is what? Done. Meaning that it will be equal to what? 0. Take note of that. Now, which means that no work is what? Is done. Another application of this is that's one of the applications we have. You can apply it in work done. When there is no work done, that means that theta will be equal to what? 90 degrees. Meaning that you give us cos 90 is what? 0. Meaning that no work is done. Now, the cross product, or what we call the vector product. The cross product, or what we call the vector product. B, the cross product, or what we call the vector product. The cross product of a vector is defined. The cross product of two vectors, let's say two vectors of A and B, gives us another vector. A cross B will be equal to C to give us another vector, and it can be defined as the magnitude of A and B sine theta. The magnitude of A and B sine theta. The cross product of that. That is the definition of the cross product of a vector. And the cross product is known as the vector product. Now, also have some of the application of this cross product of vectors. We have definition of what we call the moment of a force. Using the definition of a moment of a force. Moment of a force is just the effect of a force applied at a distance from the axis. The effect of a force. Now, when the force is being applied on an object, it has an effect. So that effect is called the moment of a what? A force about a fixed point. It starts from a point. Before any effect is being taken, before any action is being taken, it must start from a reference point. So that is the moment of a force. Is the effect of that force about a fixed point. That point can be, the axis can be 0. The original, we call axis the original point, or the point of reference. That is the axis. Another application of that, meaning that A plus B is equal to moment of a force. Another application is that A plus B represents the area of a parallelogram with side AB. Another application, A plus B represent the area of a parallelogram, which is this, A plus B sine theta. It represents the area of a parallelogram. The parallelogram with side, parallelogram that have a side AB, the area. And if A plus B is equal to 0, then you can say that A is what? Parallel to B. Remember we talked about under dot product. We said that if A dot B is equal to 0, it is what? Perpendicular, right? Take note of these 2 points, please. That's a very important point you have to take in so much calculation you are going to encounter. If A dot B is equal to 0, what does it mean? Let me ask. If A dot B is equal to 0, what does it mean? That the two angles are inclined at what? 90 degrees, right? They are at 90 degrees. That means that the cos 90 is 0. Now take note, under cross product, you can only have 0 under cross product when A and B are parallel to each other. When A and B are parallel to each other, A plus B is equal to what? 0. When they are perpendicular, remember that sine 90 is not what? It's not 0. Sine 90 is equal to what? That is it. It's equal to 1. It is not 0. So it can only be 0 when the two vectors are parallel. Take note, but under the dot product can be 0 when the two vectors are perpendicular. while the cross product can be 0 when the two vectors are parallel to each other. Another application of vector multiplication, that's the cross product, right? Another application of this, take note, this dot product that is being written as A plus B equals modulus of A and modulus of B sine what? Theta. Can also be given as A. You can B plus A equals modulus of B modulus of A into brackets sine into brackets 360 minus what? Theta. Now, the value of this will give you the negative of that. The value of this second one now will give you the negative of that. If this is equal to C, remember the cross product of A and B gives you another vector C. Now the cross product will give you a negative minus what? C, meaning that here B plus A is equal to what? Minus C. And here A plus B is equal to what? C. That's another application of this cross product. The cross product of vector can be given. Watch your textbook properly. Read it. There's an angle there how that 360 is being gotten, because I'm just trying to see if we can cover what we are supposed to do. So these are the application of a vector. Now take note. Here we have that A plus B can be equal to C and can also equal to minus C. Their signs can change based on the last application. That is what we can see under vector multiplications and what? Which is vector multiplication, the two vectors that has to do with multiplication, that the dot product. And when we talk about vector multiplication, we talk about the dot and the cross product. Now, these vectors, they don't have vectors in 2 dimensions. Vectors in 2 dimensions. Remember that this topic centers on vectors in 2 and 3 dimensions. If you watch that topic. Now we have vectors in 2 dimensions. Where we have the unit vector I and J. The unit vector I and what? J. When we talk about vectors in 3 dimensions, talk about I, J, what? K. You know the unit vectors. You know the I, you know the J, you know the K. They are the unit vectors. So I want to talk about the vectors in 2 dimensions. Vectors in 2 dimensions. Let's also use a perpendicular triangle or the right angle triangle when we are talking about 2 dimensions. We have only the X, the Z, and the Y direction. If we should consider this triangle or diagram or right angle triangle that has the Y and X direction. The Y can be taken as the J, the unit vector J. And this can be taken as what? I. Now if we have this to be AX, here become AX, maybe it's a vector, we say vector A, and here can be AY. Remember, we can still have a diagonal. If you have a diagonal drawn, which you can form an angle. Now, looking at that, we can calculate the value for A. If you want to calculate the value of A there now, A is the vector. The unit vector Ij, we are talking about 2 vectors, can't put K. Now if you want to calculate that, A is the vector A. The vector A can be represented by both directions. AX sub J plus ay sub I sub j. The unit vector I, j, k, they have the magnitude. So this unit vector I, j, and k, this unit vector I, so we're talking about vectors in two dimensions, not three. Vectors in 2 dimensions, only I and j. Here, if we want to calculate, we can also calculate ax and ay, which I told you. We've already talked about the formula. Ax can also be given by a cos theta, and ay can also be given by a sin theta. Now the modulus, you cannot calculate the modulus or the resultant. The resultant of this vector can also be equal to this. Square root of this. You can also calculate the resultant or the modulus can also be equal to ax plus ay. This is exactly what is happening here. But base means that we have ay, j, and the rest of them. When we get into the application, we will know better. Now, let's see this. Also, the direction is also the same. The direction is as far as it's inclined at angle 90. Note that I've told you when a vector is being inclined at angle 90, how to calculate the direction and the what? The magnitude or the resultant. Since this is the resultant, the direction theta also has to be tan inverse of ay over ax. That is also that. Now let's see this example in your book. The magnitude of a component of a vector C along x and y axis are, we have a vector C. That vector is C now, no longer vector A. That is along x and y was axis. This is now cy, and this is now cx. And C is the magnitude of the component of a vector C along x and y axis are 8.7 and what? 5 Newton. If here is 8.7 Newton and here is what? 5.5 Newton or 5.0 Newton. You said 8.0? It's 5. Let's use, okay, 8.0 is your third. Sorry. 8.7, sorry, not 7. 8.7 Newton. Now, if that is 8.7 and that is 5 Newton, you have to calculate their direction and their what? The magnitude. It's just you having this that you cannot say that the magnitude C is equal to Cx plus what? Cy square or square. When you square root and put the value of Cy, you have that Cx is what? 5 Newton. Cx is what? 5 Newton, right? 5 Newton squared plus Cy. This is Cx. This is Cy. Then our Cy is what? 8.7 squared. Or what? Square root. That is your magnitude. The magnitude of this C gives you that. Now 5 squared plus 8.7, right? That's 8.7 or 8.5? 8.7 squared. If you square it both of them, if you square them and square both of them, you have that the magnitude of this your C will now be equal to what? 10 Newton. You square this, square it, then square it them. Plus them and square it, it's equal to 10 Newton. This is just what is happening here. In these two ij what? Vector. Vector is 2 dimension. The unit vector in 2 dimensions. The 2 dimensions just the y and the what? Z and the x axis. Then we cannot calculate the direction. Remember that the direction I will now use this formula. Tan cy over what? Cx. Our cy is 8.7 over 5. When we divide it, whatever we get, we have 0 point something. Then we now do tan inverse of that 0. What did we have as the answer? I think we have 30 degrees. There. That is how these vectors, what happens in these vectors. What? The diagram 8.7. What do you have in your book? 8.7. It's 8.7. Now what is it? It's 8.7 in your book. Any problem? It's 8.7 now, which is Cy. Then Cx is 5 Newton. Then when you have Cx is 5 square and this, then you calculate. I don't want to waste much time here. Then we also have, let's now discuss on vectors in 3 dimensions. Sorry. Yes, vectors in 3. We're going to talk about the ijk vectors. Let's talk about the unit vector ijk. The unit vector ijk. Unit vector ijk. If you have this unit vector ijk, it's no longer going to be perpendicular. You are having vectors in 3 dimensions now. It's in your notes, it's in your textbook, please. Vectors in 3 dimensions. Please take care of, be careful over this vector in 3 dimensions, because this is exactly where you have most of our questions or our past questions centered on. Now, if you have vectors in z, y, and x axis, you have this vector in z, y, and x. Now if you have this vector, this is A, y direction, which you have the J, which is AYJ. This S axis, this is S axis, the vertical. Can also have, AZK. This now becomes AXI. Now if you have these 3 vectors, they have the unit vector I, this is not unit vector I, J, K. This is what we are studying, the unit vector I, J, K. Let this ijk be a unit vector along the x, the y, and the z direction. You know, this vector is along the what? The x and y and z direction. Meaning that for us to calculate the A, for us to calculate the, if you ask now to calculate the magnitude of A, what are you going to have? The magnitude of A now here, A become, because A is now in 3 dimensions. The magnitude of A now become AXI plus AYJ plus AZK, all what? Square root. If you have to calculate the magnitude of that vector, but the vector is no longer in 2 dimensions. I want you to take note of this. Take note that unit vector obeys the law of I dot I equals K dot K equals J dot J is equals to what? 1. Meaning that when the unit vectors are parallel to each other, when you have this, it gives you what? 1. It gives you 1. It gives you 1. But if A dot J is equal to K dot I is equal to, which one have I not included? J dot K, right? Is equal to 0. They are perpendicular. Remember, I told you in dot product, it is equal to 0 when 2 of them are what? Perpendicular. When you talk about IJ means vertical and horizontal, right? I dot J means that they are what? Perpendicular to each other. Now, take note of this. This unit vector, this is, will I call it the properties or what you have to know about unit vector? Unit vectors, what did I say? I say unit vectors obeys this law that I dot I equals K dot K is equals to what? 1. Meaning that I can say that the magnitude of I is equals to the magnitude of J is equals to the magnitude of K is equals to what? 1. But I dot J, because here now they are perpendicular, is equals to what? 0. Take note of that. Very, very important. Meaning that we got that from A dot B, the formula for a cross product. We gave us that. The formula for a cross product gave us that A dot B is equal to A modulus of B, right? Cos what? Theta. Remember that cos theta, when this is at right angle. When you talk about IJ means this. This is this diagram. This is J, this is I, right? Is it not true? They are at right angle. Once you have IJ, you mind that they are at what? Right angle, and it's equals to what? 0 using this formula. So it obeys this form that I dot J is equals to what? 0. Take note of that. Very, very important. Now, for instance, take note of this. For instance, take note, let me write what you have to take note under this vector product we are talking about. I said, take note that this unit vector obeys this form. 1, I dot I equals modulus of I dot I equals the modulus of I, and modulus of I cos theta is equals to 1. J dot J equals modulus of J over the modulus of J cos theta is equals to 1. K dot K is equals modulus of K over the modulus of K cos theta is equals to 1. Now, I dot J, which is equals modulus of I, modulus of J, cos theta is equals to 0. I dot K, which is equals modulus of I, modulus of K, cos theta is equals to 0. J dot K, which is equals modulus of J, modulus of K, cos theta is equals to 0. Meaning that here is that we have that A dot this and this. This is just what it means. Take note of that. That is for dot products. That is for what? Dot products. Under the unit what? Vectors. Remember, we have two multiplication of vectors. We have the dot product and the cross product. That is what we have been centering on. And that is what we have been discussing today. Now we want to talk about the cross product. That is about the dot product under there. Because we have to move into calculations after this explanation. Now we have for cross products, right? For cross products. What's another name for cross products? Vector product. Now in the case of cross products, what happened? Now recall from the formula that A cross B is equal to modulus of A modulus of B sine theta, which can also give us another vector C, right? Now if A cross B is equal to 0, that means they are parallel to each other, right? Now if A cross B equals, if they are equal to 1, they are perpendicular to each other. So look at what happened in the aspect of this. For this aspect now, A cross B, which is equal to C, which gave us modulus of A, modulus of B sine theta. Also, for the unit vector, we can have A cross J, which is equal to the modulus of I, modulus of J, sine theta will be equal to what? K. Remember that the modulus of those two vectors gave us another vector K, another vector C. Now applying it to the unit vector, we are discussing on the what? Please pay attention on this topic, because what it has to do with vector, if you have vectors question in your exam precisely, it's being centered on this unit vectors. They don't even pick exam from resolution of vectors. They can pick for addition, but mainly on the unit vector. That is where the question is normally centered. Then we have A does D is equal to C is equal to K. Then this unit vector J cross K will be equal to another vector what? I. We now have the modulus of J or the modulus of K sine theta is equal to what? I. And so on and so forth. You can also interchange. Which one have we not written? We are not using I and K, because modulus of I cross K can give us modulus of I, modulus of K is equal to what? J. From this, the cross product of that vector will give you another vector. So in the unit vector, the cross product of that gives you the K and the rest of them. Those are the properties. This thing we are discussing are the properties. This thing we are discussing are the properties, what we are supposed to know about this. Now using the order, remember the first order I said. Using the order, also the order of A. Using this order, there's the one order I said that using this order also, I don't want to clean this diagram. Using this order also, we are done with the properties of dot product under the unit vector. We are now going with the properties of what? Cross product under the unit vector. Now if you also know that from the other formula I use, that A cross B can give us minus C. Meaning that when you also have the modulus of that, you can also have this to be also J cross I can be equal to minus K, and K cross J can be equal to minus I, and K cross I can be equal to minus J. Using this, remember I wrote, there's another formula when I put 360 minus that. Yes, anything you give me B plus A, you know what I mean by that. Cross product of this. You remember when I used that formula 360 minus, you get a negative value of this. It's also applicable to these properties of these vectors. Now, having talked about, take another properties of this is that I cross, have I written that? No. I cross I equals J cross J. I'm talking about properties of cross products now. J plus J, this is very important, equals K plus K is equals to what? Who can tell me? It's equals to what? It's equals to what? What is it equals to? How is it equals to what?
When they are parallel.
When they are parallel, they are what? Under cross product? 0. Have you forgotten? When they are parallel, I told you that take note, under cross product, when they are parallel, it's only when you have 0. When they are at right angle, when they are perpendicular at 90, you have what? 1. Remember that sine 90 is what? 1. But when they are parallel now, you equal to what? 0. Take note of that. But if you have this another property, I cross J is equal to I cross K is equal to J cross K is equal to what? 1. These are the properties of these vectors I'm writing for you. Following the formula of A cross B equals magnitude of A, magnitude of B sine what? Theta. Now if you plot sine theta, which is 90 here, find out it's equals to what? 1. Following that formula. So those are things you should know under the cross product and the what? Dot product under unit what? Vector. Under unit vector. Then when you have I plus I, when they are parallel, they are equal to 0. When they are perpendicular, they are under cross product, they are equal to 1. Then under dot product, when they are parallel, they are equal to 1. When they are perpendicular, they are equal to what? 0. Take note of that. Very, very important. Now, let's discuss on calculation. Vector additions and subtraction. Vector additions and subtraction. Vector, I have to hurry up with this because my time has said, but I want to finish this. If I didn't teach this, I will not teach it again. I'll move into another topic. And this vector addition and subtraction is what under this unit vector is very, very important. I can only, let me just, sorry, I have to clean this diagram. I'm already exhausted, but I'm just trying to see if I can just, I'm supposed to have this period, 2 periods. 1 period is not enough for me for anything. Now, vector addition and subtraction. Let's talk about under dot product and cross product. That is what we are centering on. Under dot and cross product. For under dot product, A dot B, we can have, when we have a vector, 2 vectors, A and B, you can have, if you want to calculate, you can have that AX, BX, plus AY. Remember, we're talking about vectors in 3 dimensions. X, Y, and what? Z. B, sorry? AX,
Y,
AX,
Y.
hold on. We have, we have 2 vectors, A and B. If you have, A will have X, this. Under Y, you have AY, BY. Under Z, you have AZ, BZ. This is what you have. You have 2 vectors, A and B, that are at 3 dimensions. They are being inclined at what? 3. That we are talking about vectors in 2. We are done with vectors in 2 dimensions, where we have the I and the J. We are talking about vectors in what? 3 dimensions. We have the X, Y, and the Z axis. If you want to calculate them, you must calculate A under X axis, B under X plus this and this. That's how to calculate that. Now, the dot product of that becomes that for the addition of vector. If you want to add those vectors, that is how to add them. Now, cross product is where we have a little bit complication there. When you have this is for dot products. If you want to add these vectors, A dot B, ASBS plus AYBY, this is the, at the end, if they have given you the values, sum the value, that is your A dot B. Now for cross products, is it going to be the same? No. For cross product, we have the I, the J, and the what? And the K. Now, if you have that, we have AX, A1, AZ, right? We have A, we have BX, we have B1, we have BZ. Now, how can you calculate A cross B? How can you calculate A cross B? We are talking about addition and subtraction. How to calculate A cross? It's no longer going to be this plus this as we did. A cross B now will not be, for us to get A cross B, and you close one, look at what how we're going to get the formula. A cross B equals, close this. I get what I'm saying. If you close it, what will you have? AYBZ, right? Right? AYBZ. Close this, you're having AYBZ minus AZ. You should be giving me that. This is not the minus AZBY plus, this is for I. This is for what? For I. If you want to calculate for I is a what? Remember, this is a unit vector I, this is a unit vector J, this is a unit vector K. At the end, if you get 8 here, these are 8I, 9J, if you have gotten, let me assume, they are giving you the value at the end, this is how your answer is going to be. If the whole of this is 8, you have 8I plus 9J plus 10K. This is how your answer will be. Now, under this, for you to calculate under dot product, what do you do under? You close anyone you are calculating, close that one. Now, this is the formula I'm stating for you, very important. If you are calculating for I, let's close I. Then this goes to this goes to this, which you have AYBZ minus AZBY, all of what? I. Plus, we now move into J. We will now close J. When we close J, what are we going to have? AZ, we can have AZBX minus AXBZ. All into what? J. Plus, we close K. When we close K with our hand, we are going to have, right? Yes. AX, BY minus AY, BX, or K. This is the formula for the cross product. Whichever value they gave you as AX, whichever, all these things have to be, they have to give you the value. Anyone you're calculating, close that one and get the that. So this is the formula on how to calculate for the multiplication of cross products. Now, you know, this product, I told you that one of the application of the cross product is that it is applied in the area. Here it can also be applied in the volume. Volume, we can have cross A, cross B, and cross C when we have up to 3 vectors. Remember that volume can be Q. When we have, it can also, each application can also be applied in what? Volume of a what? Parallelogram. A parallelogram of what? A, B, C. One of the applications, it can also apply in parallelogram vector A, B, what? C. Take note of that. Now, if you have, let's see an example of what you have done. Let's look at this solving. Then I will give you one in your past question paper. Let's look at this. This is the dot product. We are done with this. Are we not done with this? This is the dot. These are the properties you should take note of. Now, let's do this example. Now, if vector B If vector P is given by 7i, if vector P is given by plus 7i minus 3j plus 2k, and vector Q is given by 4i plus 5j minus 3k. These are the things you should be getting under these vectors in 3 dimensions. These are the kind of things you should be given. Then in that question they said, calculate 1, the resultant of what? P and Q. Calculate number 1, the resultant of what? P and Q. Resultant of P and Q. B, the scalar product. The scalar product is what? P dot Q, right? Do you remember? The scalar product is also known as the dot what? Product. P dot Q. And lastly, the cosine and angle between them. Meaning that C now says the cosine and angle. I remember that the cosine and angle said that P dot Q is equal to magnitude of P over magnitude of Q plus what? Theta. This is what we are going to call the cosine angle. So you make the cosine separate on the formula. How do we go about it? How do we go about it? Remember, this is the one we say. Remember this? This method we are going to use for that. Although there are up to 3 vectors. What are we going to do? We have to plot them. Remember that our formula says P dot Q. First of all, you should calculate the magnitude, right? The magnitude of vector. The magnitude of P now becomes P magnitude is equals to what? P magnitude is what's the formula for that P magnitude? PS, PY, and PZ. Is it not true? It's equal to the PX squared plus PY squared plus what? PZ squared. By that time, this is your S, this is your Y, this is your Z. In order not to forget, you label them. This is your S, this is your Y, this is your what? Your Z. You label them like that. Which one is our PX? PX is 7, right? 7 squared plus PY is what? Minus 3 squared, right? PZ is what? Plus 2 squared, right? All square root. What's the answer now? If you square root, then what are you going to have? I have here 7.9. I don't know for you. Do and you have it. 7.9 Newton. That is your P magnitude. Then our Q magnitude now becomes Q magnitude. Our Q magnitude now becomes Q of S square plus Q of Y square plus Q of what? Z square. This is QS, QY, and QZ. Sum them up. Put the values. What do you have? QS is equal to 4, right? 4 squared plus 5 squared plus minus 3 squared. Anything minus squared it becomes that. When you square root all of them, I have here 7.1 Newton. This is the magnitude you're asked to find. Then for you to find the scalar product, the scalar product now becomes P dot what? Dot Q. How do we calculate the? Remember I gave you the formula for that. P dot Q now becomes my already. Let me just now let me give you the formula. P dot Q now becomes, look at it, Px Qx plus Py Qy plus Pz Qz. This is what you have. Add all of them together. Well, remember that this is equal to what? I. This is equal to what? J. This is equal to what? K. Right? By the time you know your PQ is what? this will now be this sign this, right? Which is equal to P dot Q now becomes our P dash is what? 7 times what? 4, right? Plus our PY is what? Minus 3 times 5, right? This is I, this is J. Plus our PZ is what? 2 times minus 3, right? Of what? K. This sign this plus this plus this plus this. After you get a PQ, now P dot Q now becomes, this is what you have 28 and minus 15J plus, minus 6K. This is how your answer will be. You must leave your answer in IJK. We are talking about unit vectors. Then they now ask you to calculate the what? They told you to calculate the what? The angle. The angle now, because you now make cos theta subject to the formula. Remember that A, P dot Q is equal to modulus of P, modulus of Q, cos what? Theta. Make cos theta, so you have a cos theta is equal to P dot Q all over modulus of P over the modulus of what? K. I know what modulus of P. Have you calculated modulus of P and Q, right? We have done them. You just take them. We have modulus of P and modulus of Q. P dot Q, have you calculated P dot Q? We have calculated P dot Q. Now plug in the value of P dot Q, which is what? Which is 28. Which is 28 what? 28 minus 15 will give us what? 28 minus 15 minus 16 will give us what? 7. We have 7 all over. Modulus of this and this will give us what? This and this is what? What it gave me here? Say 56. And I have 56. 7 over 56 gave me 1 over 8. And I have that, which is 0.125. 1250, which is cos theta. Now my theta becomes cos inverse of 0.1250, which gave me my angle as 83 degrees. So these are what you'll be expecting. So I want you to go and study your questions. Take this question under your past question and just solve. I want you to go and study this. I think I have to end here because I'm already exhausted and you're exhausted already. That's why I said 1 hour is not enough for me to teach. I wanted another hour, but unfortunately, the chemistry people came today. Now take this question under vector. If I say that coursework, I should give it to them. They may not pass to you. I know those coursework. Take this vector. If vector A equals, if vector A, are you writing? If vector A, let me just give it to you and we'll start going, please. I'm exhausted and you're exhausted. If vector A equals I plus 2K minus 3K. If vector A equals I plus 2K minus 3K. think you have to end here. Look at it. Look at I said that's I said fancy, right? Yeah. 2A, right? 2A minus 3B plus C is equal to 1, 0. You are finding the value of C. So, having exhausted today's lecture, I think you have to call it a day. Those that want to submit their attendance of last week, not today. Please, I think. Today, no attendance because some of you are already preparing for matriculation. My name is come and help me carry the report. Let me start. I'm done with this topic. I'm moving it to next.